Yes, so far we already discussed all the DevOps tools like Linux, GitHub, Maven, Tomcat, Jenkins,
No.
right? We already know how to deploy an application. Okay, we already know how to deploy an application. We already seen that by using Jenkins CI/CD tool. Okay, so for that. Okay, today our topic is Docker guys. Our topic is Docker. Our topic is Docker guys. Okay, in this Docker, what are the components we are going to be discussed here? First is introduction. Okay, it is very, very important for the Docker. Okay, and next one is virtualization and containerization. And what is a virtual machine? What is a Docker? What is the difference between these two? And after that, installation. Then how to create a Docker file and Docker images and Docker containers by using Docker commands. These are the things we are going to be discussing. Okay. Before that, see, in olden days, how we are going to be deployed in 1990s. There is a physical missions are available in 1990s. Okay, build and deployment process. How it is available in old days? There is a we have a physical missions means our desktop. Okay, our desktop missions like that. Okay, in that we are going to be deploy our application as a hosted and server. Okay, after 2000 we have a virtual missions. Okay, we have a virtual missions. In that, by using these virtual missions, okay, we are going to deploy our applications, guys. We are going to be deploy our applications. Okay, coming to 2013, we have a containerization tool is there. Containerization tool. For example, in this containerization tool, we are going to be used as a Docker, guys. Docker is a containerization tool. I'll explain what is the Docker containerization tool, what all of these things. It is a applications how we are going to be deploy our application in different years. Why we are going to be use this Docker and all those things. That is we are going to be explaining here. Okay. See here we are going to be 2013. It is came as a Docker containerization. Okay. In this we are going to be package our application. Package means see var or jar files, right? In that application we are going to be deploy after build we are going to have a build our application. Okay, it is coming to as a package, yes. It is coming to package like jar or war files. And it is dependencies also. And it is dependency. Dependency is nothing but new features, yes. New features or libraries, anything. Okay. So that what are the developer will be releasing working, okay, regardless of which environment. Environment nothing but platform guys, like dev, QA, pre-prod, staging environment, like that. Okay. These are the environments we are going to be deployed. I will explain these things. Okay. First, we are going to be explain these physical missions, guys. These physical missions. See, in physical mission means what are the things are available? See, in physical missions, we require on physical mission hardware. See, hardware, CPU, RAM, like that. We need to require, right? And automatically we need to install in that Linux or Windows or Mac OS like that, right? Then, what are the project are going to be developed? See, here we are going to develop as a Java-based projects, right? Java-based project. In that time, what we are going to do? We are going to do install Java applications, that means softwares, okay, and Maven build tool. After that, Tomcat our deployment server. See like this, see Maven web application, our source code Java applications, .js files, .html files. All these things are we are going to be installed in our machine. Then only we are going to build by using this Maven tool. We are going to build. Then only it will be coming as a .war files. It will be generated. .war files it will be generated. Okay. Then these war files are going to be deployed our application. This package are going to be copied in Tomcat web server. These things we already seen that, right? But in old days, in 1990s, we have physical missions like this. Okay. In that physical missions, we are going to be install OS and all those things. And what are the project we are going to be see. Now I'm going to be using as a Java based. Okay. That's what I install this Maven and these all these things. If I'm going for the Python means Python related software, I'm going to be installed. Okay, there is a pip tool will be there. I'm going to be install that pip tool. Okay, by using that pip tool, I'm going to be do that build and all those things. Gradle also you can do it. Okay, based on your requirement, based on your project. Okay, then I'm going to be web server. Okay, I'm going to deploy on web server. It is a Tomcat. Okay, it is in old days. It is like this only. Then after that, we're getting as a 2000s like that. We have a virtual missions, guys. We have a virtual missions. We have a virtual missions. In these virtual missions, see if you can see, this is my physical mission. First, you can take it as a on physical mission. There is a hardware you can take it as a 8 CPU, 32 GB RAM. Okay, 8 CPU and 32 GB RAM. Okay, in that physical machine, you already install one OS, Linux or Windows. Okay, that is called as a host OS. Guys. That is called as a host OS, which is you install in your machine. Okay, after that, inside your machine, you are going to be installed one hypervisor, guys. One hypervisor software. Okay, one hypervisor software that is called as a VMware or RKL, VirtualBox or Windows Hyper-V. Okay, see, it is going to be similar like this. There is not there here. That is one of the software, guys. VMware means, see, like this, we have a VMware. See, in physical machine, you are going to be install one software like as a, see, you are going to be install as a one software that is like VMware or Oracle or VirtualBox or Windows like that, you are going to be installed. After you install this physical machine only, okay? After you install your physical machine means see your infrastructure, CPU, RAM and everything. Then your host OS or Windows or Linux, anything. Okay. Then only you are going to be install one software. Okay. That is based on the your requirement or virtual box or Oracle like this. Then inside this, after you installation this software, it will become like this, guys. It will become like this. It will become like this. So it will become like this. There is a workstation, it will become, you are going to be create as a virtual missions. You are going to be create as a virtual missions, guys. Like this, it will become. Okay. Then inside that, you are going to be install again. There is a Linux or Windows, guys. You are going to be install Linux or Windows. It is called as a guest OS, guys. It is called as a guest OS. Okay. It is called as a guest OS. See, by using this software, I'm going to be create number of virtual machine based on the your hardware requirement, based on the your hardware requirement, guys. Based on the your hardware requirement. See, based on the what are the your hardware requirement? See, it is my hardware is 8 CPU and 32 GB RAM. So I'm going to be divided. I'm sorry, I'm going to be divided. See how I'm going to be divided. See, here is first is 2 CPU core, okay, 8 GB RAM. Another one is 8 GB RAM, 2 CPU core. Okay, another one is 2 GB RAM, 2 CPU core. Like this, I'm going to be divided into three virtual machines. Okay, like this, I'm going to be divided into three virtual machines. See, based on the your hardware requirement. See, in that by using this software, I'm going to be created three virtual machines. Then again, inside virtual machines, I'm going to be install this Linux software or Windows software. Okay. Then after that, my project. What is my project here? Java based project. Okay. So Java based project. Inside this softwares, see, inside this, see like this only. Inside again, I'm going to be install this Maven, Tomcat, this Java web apps, whatever the things based on the your project. Then I'm going to be deploy our application like this only. Okay. It is after 2000s. This is called as a hardware level virtualization, guys. It is called as a hardware level virtualization. After that, we got as a Docker, guys. After that, we got as a Docker. Okay. After that, we got as a Docker, guys. See, what is this Docker? Okay. In after 2013, we got as a Docker, guys. We got as a Docker. What is Docker? Docker is a containerization platform. Platform is nothing but environment, guys. Okay. Platform is nothing but environment. Okay. Docker is a containerization platform which packages your application. Which packages of your application and it's all dependencies together in the form of containers, guys, in the form of containers. So that ensures that your application works seamlessly in any environment, like dev, QA, staging, pre-production and production environment, like any environment. If you can see, like environment is nothing but dev, test and production environments. Seamlessly, it will be going to be run, guys. See here, if you can see here, it is going to be packaging your application and all your dependencies together, and application plus your all dependencies together. See, here is I given as some example. Here is I given as some application. See here, what I'm going to do is, see, it is packages means directly I'm going to be build a application. Okay, all the software packages it will become like that, means packages means .war, .jar, for all packages it will become your like as a application. Okay, then all dependencies also it is coming as a together in the form of containers. Okay, in the form of containers. See, in that form of your containers, seamlessly you are going to be deploy your application in different environments. Okay, Docker is a open source platform, guys. Why I'm going to be choose this Docker? Docker is a open source platform for the developers. Okay, then they are easily build and ship and run the distribute the application in different environments. Okay, run and ship into the your application in different environments. That's what I'm going to be using here as a Docker, guys. And Docker is also available is two versions, guys. One is community edition, another one is enterprise. Community edition is price, guys, licensed version. Sorry, community is open source, guys. Community is open source. Open source is nothing but free, guys. Okay. Enterprise edition means it is a licensed and it is providing as a some cost, guys. It is providing as a some cost. See, for example, how I'm going to be run all my applications. If you can see, I'm going to be run as a base image and plus all the configurations and dependencies, that nothing but softwares and my application. This all together is coming to as a forming as a containers. Yes, coming to as a forming as a containers. Then only I can easily ship into the any environments and run in different environments. That's what I'm going to be use as a Docker as a containerization. I'm going to show you. See, this is physical machine. First one. Okay, in this physical machine, I'm going to be install what are the softwares required and what is the deployments of. I'm going to be install like this. After that, virtual machines. See, based on your hardware requirement, hardware level virtualization I have done. See, that means I need a one software like a hypervisor. Hypervisor means inside there is a lot of software available like a VMware, Oracle, VirtualBox. After this, I have a guest OSS. After that only I install this softwares and everything. Then I'm going to be build our application and deploy our application. Okay, this is a hardware level. See, coming to this Docker, guys. Coming to this Docker. Okay, coming to this Docker, what it will be happen? I don't need any software, guys. I don't need any software. See here, does not require any guest OS. It shares the host OS based on the containers. If you can see, here is I have to one software required. Virtual machine, I need a one software machine that's required. Okay, but here I don't need, guys. Here I don't need any softwares. Directly it is taking as a your host OS. Okay, Docker, see, does not require any hypervisor softwares. Docker is a containing the packages itself only. Okay, and these packages can be run as an application in any environment. Okay, in any environment. But here, if you can see in this virtualization mission, see, required one guest OS, need one hypervisor softwares to create a virtual machines, and these virtual machines having a different system requirement. Okay, what are the system requirements? One is CPU, another one is memory, another one is storage. These all are will be taken from this physical machine. That's what I called as a hardware level virtualization. That's what I call as a hardware level virtualization. All this one will be taken by the from your host machine, guys. From your host machine. See, that's the thing only I written here. Okay. See, what is this main difference means? See, I will take one scenario. In this scenario, see, two Tomcat applications I'm going to be installed, guys. Two Tomcat applications I have to install. Okay, see here. Here is Tomcat 9, here is Tomcat 10, like that I'm going to be installed. You can take a one scenario like that. In same machine is not working because of this isolation process, guys. Because of this isolation. What is this isolation process? Is nothing but this process level and user level and storage level and this network level. See, if I install this different OSs, see these are dev environment like that, you can take it. Another one is test environment. Here is I install as a Tomcat 9. Here is I install as a Tomcat 8, guys. See, whenever I'm going to be deploy our application dev environment, it is going to be successful in dev environment. So same thing I'm going to be installing test environment, it is going to be fail. Because of here I changed that software. Okay. That's what it is not going to be perform in testing environment. Okay, it is not going to be performing testing environment, guys. That's what it is going to be fail in test environment. This is the biggest drawback in this virtual machines, guys. Biggest drawback in this virtual machines. Okay, that's what we have we got it as a Docker, guys. That's what we're getting as a Docker. Okay. See, in this virtual machines and containers, see here is a virtual machine as a heavyweight. Okay, heavyweight means we cannot able to move one area to another area. Okay, but containers are very easy and lightweight containers, guys. Very easy and lightweight. How I am going to tell based on the your hardware level virtualization here, it is OS level virtualization. What is this heavyweight and all those things? Here I already read. See, why I am going to tell you heavyweight means, see, these hardware requirements are very cost, guys. Very cost. Okay, you cannot able to move one area to another area, and we cannot able to purchase every time. Okay, and every time we cannot able to increase our CPU, memory, and this hardware utilization, all these things. That's what I call that say heavyweight, guys. Okay, and it is not easy to move one area to another area. But if you can take a containers, what it will be take? See, simply I am going to be run as a my application as a container. Yes, my application inside container. What are the things available? My application code, my softwares, my environment, everything I am going to be make it as a container. Yes, everything I make it as a container. In this container, I can easily ship. Okay, I can easily ship in different environments. See here, which is required run as a piece of software. I can run any environment. That's what I called it as a lightweight. That's what I called as a lightweight, guys. Okay. See, these are the limited performance. Limited performance means based on the your requirements only, it is going to be performed, guys. That means how your system will be performed based on the your resources. What are the resources? CPU utilization, this network utilization, your storage utilization. These based on this performance only, it will be work, guys. This is worked as a native performance. It is worked as a your native performance. Native performance, it is behaved say own, guys. It is behaved like as a so own. Okay. And each virtual machine run it says a own OS. Own OS means like just before I told you. See, own OS means see here I'm going to be run as a Linux guest OS. Okay. Another one is Windows. Another one is Mac. Like that, based on the your requirement, you are going to be run. Okay. But here all containers it will be run as a host OS. Host OS means see which is now my OS is here is my host OS is Windows, guys. Okay. Here my host OS is Windows. Okay. In that based on that OS only it is going to be performed, guys. But here is in virtual machines is different it will be run, guys. And that's what I called as a here is it is a hardware level virtualization. Here you are going to call it as a OS level virtualization, guys. OS level means it is based on the performing your your host OS only. Here it will be performed as a your hypervisor. Hypervisor. I'm going to take it here as a virtualization missions. I'm going to take it as a one software, guys. That is called as a hypervisor. Okay. That's what it is here showing as a every virtual machine it is showing as a one. That is here it is coming as a guest OS, but here it is coming as a our own OS only. Okay. See, these are hardware level. Based on the hardware level only, you are going to be create number of virtual machines like this. Then only you are going to be install this CentOS or Windows anything. Okay. But Docker not like that. See, Docker is directly going to be Docker directly we are going to be installed and directly our application will be container and are going to be deploy your application, guys. See, these are examples which is I written here. See how it will be working as a virtual machine is heavyweight. See, these are Docker is less weight. See, it will be run as a like I said Tata is, yes. But whenever you are going to be start in a Docker, it is going to be run as a Kangaroo. Kangaroo is it means it will be start up and very easily it can run very easily, guys. And if you can see here, it is getting as a interaction is a difficult. Here interaction is very easy. That's what I written here like this only symbols. All are I took it from internet only, guys. Okay, you can check in internet also. See, here is hardware level virtualization I told you, right? Based on the your infrastructure. Okay, based on the your hardware infrastructure, you are going to be created as a some virtual machines. See, but here it is a OS level virtualization. It is called as a OS level virtualization. Why? Because all containers will be run as a your host OS machine. See, here startup it will be taking as a some time, but here it will be when you start the container, it will be taking as a within seconds. I already showed you how it will be run one application as a container while installing SonarQube, guys. While installing SonarQube, it will be run within seconds, guys. Within seconds, and see, it will be required all the memory, CPU, and everything, but it does not require any memory space and all these things. But it is required, but it is a very less, guys, very less. But here you have to give as a some memory, CPU, all the things you have to provide as some storage, like a virtual machines. But in host OS, but in Dockers, you don't need to require all these things, but it is a less memory it will be take. And it is fully isolated and more secure. Virtual machines, fully isolated and secure. But it is a process level isolation, guys. Process level isolation and possibly less security is available. That's what inside the companies they are going to be using as a firewalls. They are going to using as a firewalls. That concept will become in AWS. Don't worry, that I will tell you. Okay, that's what companies are using as a firewalls inside companies. Okay, these are type of Docker, guys. Docker containerization tool like that. I written it. It is a. If you want, you can go and directly visit this website, guys. If you want, you are going to directly visit this website. See, is it a open source means? Yes. Okay, my vendor is here, Docker. There is a lot of tools are available in market. There is a lot of tools. Lot of tools means see, Container D is there, Rocket is there, CoreOS is there. Like that, there is a lot of software still available in containerization tools. These are all the containerization tools, guys. Here is I took it as a containerization tool as a Docker, guys. Okay, my vendor is here, Docker. Is it open source means? Yes, it is a open source. Cross-functional platform means it will be running in any environment. Any cross-platform means it will be run as a any OS, guys. Any OS means see, I can run in Windows, I can run in Mac OS, I can run in Linux, CentOS, Debian, SE Linux, and Red Hat Enterprise Linux. It will be run any operating system, guys. This Docker will be run any operating system. That's what I written as a cross platform. Okay, that is the thing is the cross platform. This is the Docker containerization tool, guys. This is the thing we already did. Why it is scaling like that? See, this is the difference. Why it is going to use. Okay, just you can go and read. Okay, I will share this thing. And this Docker will be run. Main it is a Docker architecture, guys. Main it is running as a Docker architecture. See, what is this Docker architecture? See, whenever you are going to be installed we have to follow this architecture method, guys. We have to follow this architecture method. Okay, see here, Docker contains three major components. Docker contains three major components. One is Docker client, another one is Docker daemon, another one is Docker registry. These are very important. This thing is very important. Okay. See, Docker, how it will be running is based on this architecture only. Okay. In this architecture, we have a major components. Okay. We have other components, other key components also. Okay. But here is the main is how Docker architecture is. This is a Docker client, Docker daemon, Docker registry. If you can see this Docker client, what it will be doing. Okay. This is the command line interface. Okay. This is the command line interface through which the user send the commands or instructions to the Docker. To the Docker. Whenever I'm going to be install Docker, there is a, it will be coming as a Docker command line, guys. Then there you are going to be using your all the Docker commands or instructions to this Docker. Then these Docker commands, it will be going to be instructions to this Docker. Then this Docker, what it will be do? There is a Docker daemon will be there. Docker daemon will be there. See, whenever Docker daemon execute the all these commands sent by the user, guys. Sent by the user. See, here is I am as a Docker user. Okay, or else Linux user, or else Ubuntu, or else ACT user like that. Okay, these commands may be installing by the OS or pulling your image from registry or running containers, guys. Where it will become? It is coming from your OS or pulling the image from your registry or running the containers. Then only you are going to be execute your commands, all the commands. Okay. See, simply whenever I'm going to be pulling this OS, there is a Docker registry also will be there. Okay, we are going to be store all the our images in this Docker registry. I will tell you what is this Docker registry. Don't worry. Okay. See, whenever I'm going to be installed, okay, that time automatically this Docker daemon also it will become, guys. That time automatically this Docker daemon also it will become. Whenever I'm going to be run any commands, first it is going to be talk with this Docker daemon only. Okay, by Docker daemon only. All these commands will be sent by the user. Okay, who is the user? I am the user only. Docker. Okay, it just for example, you can take it as a Docker. Okay, it is going to be talking to this Docker daemon. Then it will be executing all the commands by using this command line interface only. Okay, and coming to this Docker registry. These are central repository, guys. These are central repository. Okay. These are central repositories. And this central repository maintaining by the Docker only. This is Docker only. Like our GitHub, guys. Like our GitHub, there is a Docker registry also will be there. Okay. This is maintained by the, this is a central repository, guys. That's what it is maintained by the Docker only. Okay. And it is called as a Docker Hub. This registry contains various public images, guys. Various public images. Okay, that can be used. See, just before I told you, whenever you want to install all these things, okay, whenever you are going to be install all these things, you are getting as a, okay, you are getting as a some images you are going to be pulling, right? You are going to be pulling, right? You are going to be pulling the all these images to running as a these Docker commands. Okay. In this registry, we are going to be sorry. Yes. See, in this central repository, there is some public images also. It is available. I will show you once I log in. Okay, I will show you what are the images here. It is available. Okay, don't worry. Some public images also it is available. What are the images you required? See, for a Linux image or a SonarQube. Last time directly I downloaded from some community edition from SonarQube installation. If you can see, go and see that SonarQube video. I installed as a SonarQube as a Docker container only. Okay, if you can see, it is, see, in that public image directly I took it from the Docker registry only. Docker registry only I took it from that SonarQube. Okay. Again, I will show you, don't worry guys. Again, I will show you how to pull the images from this Docker Hub. Okay, how to pull these public images from this Docker Hub. But company, we have private repository is there, but that is not a central repository, like a same GitHub like that. Okay, all these images are going to be stored, guys. Okay, and this, and also users can create their own images and upload their images into the registry, and either public or private. Public means anybody can access, guys. Public means anybody can access. Okay, private means it is accessed by only company inside, whoever the persons getting a access. Okay, those people only they can access, guys. In these public images, what are, see, in Docker images, what are the things it is available? In this image only, we have our softwares, our packages, and everything. Our platform softwares, everything it is available, guys. Our application code and everything it is available. Okay, if you can see this image, see here is the user is there. Okay, here is the user is there. See, whenever he is going to be run, see after installation, it will become, guys. See, he is going to be pull, he is going to be run by using this Docker commands. Docker pull, Docker commands always starts with Docker, guys. Docker commands always starts with Docker. If you can see here, Docker client, I'm going to be using these commands: Docker pull, Docker run, Docker build. Okay, like this, I'm going to be running my client mission. What it will be happen in my Docker host? What it will be happen? See, in this Windows, I install Docker, guys. I install Docker. Then whenever I'm going to install Docker daemon, automatically it will be by using these Docker commands. I'm going to pull. I'm going to be run. Okay, I'm going to be run. I'm going to be build the images. See, like this. Docker Nginx image. I'm going to be building here. Okay, and I'm going to. Okay, what are the images? So I'm going to be store these images into this Docker Hub. I'm going to be run these images into Docker Hub or Docker registry, guys. Okay. And these are the main important of the Docker architecture, guys. Okay. I will show you physically also. Today is only theoretical part only. Okay. See, if you can see these Docker key components, we have a Docker file, Docker images, Docker compose, okay, Docker volumes, and Docker Swarm also it is available. These are the very, very important components. While we are going to be deep dive, that time we are going to be explain what are all these things. Okay, just see. You can see this. What is this Docker file? See, Docker file. It will be describe the steps. Yes, it will be describe the steps in order to create a Docker image. In order to create as a Docker image. See here, I already told you while creating, see there is a public images that can be used. Also, user can be create his own images, guys. His own images he can create and he can upload that images into the Docker registry. How I am going to be create an image means by using this Docker file, guys. By using this Docker file, I am going to create as a images, guys. I'm going to create as a images. Okay. The Docker daemon runs the instructions in the Docker files. Okay. Docker file having some of the steps will be there. Steps or instructions are available. Based on those instructions only, this daemon will be run, guys. Okay, it is called as a from top down. Okay, it is called as a from top down. Okay, so you should be orderly, you should be right as a accordingly. That means you should be right as a, there is some of the instructions will be there. You have to follow those instructions, guys. That means there is a top down instructions will be there. There is a, some of the procedure will be there. We have to write like that only. In this Docker file, what are the things that is available? Our source code of the Docker image, guys. Our source code of the Docker image, it is available in this Docker file, guys. It is available in our Docker file. Okay. So how to write this Docker file, all those things I will tell you. Don't worry. Okay. And coming to Docker image. Okay. See, I written as a Docker file. Inside Docker file, what are the things available? Our source code. Our source code is nothing but our application, guys. Okay. Our application. Okay. Based on this only, I'm going to be write as a build, guys. An image is a lightweighted and standalone and executable package. And executable package that includes everything. Everything means your software. Okay, your software means your source code, guys. Your source code, your dependencies, your libraries, and your platform. That means your environment, your configuration files. Everything it is available. Okay, everything it is available in this image only. Okay, everything it is available your image only. By using, see, by using this Docker file, I'm going to be run as a Docker build command After build, I'm getting as a this image. Inside the image, what are the things it is available? Our application code, guys. Our application code, okay? And libraries and environment variables and configuration, all the things I'm going to be build like as a one image, like a build as a one image. See, earlier it is getting as a .war files, .jar files, right? So I'm going to be building everything in is a one package, guys, one package here. Inside that package, what are the things it is available? All the softwares, okay, all the softwares, all libraries, all environment variables, all content files, all the things it is available in is a Docker image, guys. By using this Docker image, I'm going to be run as a container, guys. I'm going to run as a container. I'll show you this. This is a Docker file. You can see this Docker file I'm going to be create like this. There is a, see, for example, we already done as a Tomcat, right? We already done as a Tomcat. Okay, our see how we are going to done Tomcat. How we did this? How we did done in this Tomcat? See, I have taken on Jenkins. Git I taken continuous integration man by using build. Okay, then after man and build, what it will become? Jar or year files, everything is came right. After these jar or year files, I'm going to be deploy one web server. Here web server is Tomcat. Okay, inside web server is a Tomcat. Okay, in this Tomcat only our application copied under web apps. Then only end user can access easily our application. Like this we have done, right? See here. See here. In that I'm going to be here using as a in this Tomcat as container. See inside that one I'm going to use as a copying here. If you can see under target I'm getting as a web apps, right? Under target only I'm getting as a web app. .war file is coming. Okay, so I'm going to be copying everything in under the web apps only Tomcat. See here my image as a I'm going to be running here as a I took it as a one server here, right? Now I did not able to take it as a any server, guys. See here, it's, you can take I took it as a one separate server for the Tomcat, right? But in this, I did not take it as a any separate server, guys. Any separate server. Okay, that's what it is a very less cost. Okay, see, I'm going to be run as a one Docker container here. I'm going to run as a one Docker container. How to run as a container? So I want to create a one base image, guys. I want to create a one base image. See, here I'm going to be write as a, say I already told you, Docker file and some of the instructions are available, top-down instructions are available. Based on that only, I'm going to be create one image. See how I'm going to create. See, there is some of the instructions, lot of instructions will be there. I will tell you later. Just you can remember these things. Okay. See, I'm going to be run as a Tomcat here. Tomcat 8 I am taking here. Then I'm simply after build, I'm getting as a under target. See, we have here under target what it is, I'm going to get packages. Address book.war file like that we are getting, right? App.war, web app.war like that I'm getting, right? In this war file, I'm going to be copy under Tomcat web app only I'm getting. Okay, under web apps only I copied. Okay, everything I have written in this Docker file. After Docker file, I'm going to be run as a one command, guys. I'm going to be run as a one command. What is that command? That command is a Docker build command. I'm going to be run as a Docker build command. If you can see here, Docker build. It is visible or not? Going to be. See, Docker build command I'm going to be use. See, inside Docker Hub, I'm going to be taking as a this thing. Okay. This is my Docker registry. This is my application. This is my version. This is the current directory. I will show you. Don't worry. Okay. See, like this, I'm going to use this command. I'm going to be run as a image. Yes. I'm going to create as a one image. Inside image, what are the things it is available? Container operating system. My software. My software means Java like that, guys. Okay, Java here is I took it as a Tomcat. Okay, this Tomcat and all these things and this platform. Platform means nothing but environment, guys. Nothing but environment. Okay, and my source code, guys. My source code and plus my libraries also, everything it is available in my application code. All the things are coming to under this image. Then I'm going to be use this docker run command. See this docker run command. Okay, I'm going to run as a container. Guys, I'm going to run as a container. You can see here. See here. This is the file, guys. Okay, then I'm going to create one image. Okay, then I'm going to run as a container, guys. I'm going to run as a container. Okay, I'm going to run as a container. Inside this container, I'm going to use as a docker run -d like this. One container command will be there. Then I'm going to run my application as a container. My application as a run as a container, guys. My application run as a container. I'm going to be run. Okay, what is the advantage of this Docker? See, Docker containers, everything it needs to be run. Minimal base OS, and libraries and frameworks and application code. A Docker container should be able to run anywhere that Docker can run. That means anywhere, that means cross functional, guys. That means cross functional. Okay. And it will be run. Cross functional means it will be run in any OS, like a Windows, Mac OS. Okay. Like a different OSs, it will be run. Okay, like that it is going to be run, guys. I will show you. I'll show you just a minute. See here, we have a set of instructions available. Based on these instructions only, we are going to be create one file, guys. I'll explain later. Don't worry how to create and all those things. Okay, just remember how we are going to be do by using this Docker file, and after this Docker file, we are going to be run as a build as an image. Inside this image, we have a see our container operating system and software, this application code. Then only we are going to be run our container as a application, guys. Our container as a application. Simply, what is the Docker means? We are going to be tell like this. Docker is a containerized shell by using which can be built and run our application as a container. Our application as a container. You can tell like this way. Okay. Docker containers everything. Everything means nothing but your application code, softwares, your environments, plus your configuration files. Everything it will become under only container, guys. Everything as a container. See here how you are going to be run your application as a container based on the your creating Docker file. Okay. By after that, you are going to be used as a Docker build image. Then only you can run as a container, guys. Then only you can run as a container. Okay. Inside we have a one architecture, right? Inside we have a one architecture. Based on that architecture only, it will be work, guys. Okay. Based on this architecture only, it will be work. Okay. After installation, I will show you how to run these images and all those things. Okay. These are the advantages. Okay. These are the advantages, guys. These are the advantages of the Docker. Okay. Same thing only, which is minimum base OS and all these things. And this coming to this monolithic and microservices architecture, you can see monolithic architecture. This is the old method, guys. This is the old method. That means earlier days we are going to be used like as a see one application. See, monolithic application as a single code base. Single code base means multiple modules it is available, guys. See, that means everything it is available in only one architecture, guys. Only one architecture. That time, this user interface, if you can modify any changes in one single module. For example, there is a lot of modules are available inside one application. For example, you can take it as a one Amazon or SBI application, anything. Okay. There is a lot of modules will be there in that user interface. Okay. There, if you want to update any software, you have to stop this entire server, guys. Then only you have to upload your application. Then only you have to upload your application. But nowadays, what it will be happen? We have a microservice architecture. Microservice architecture means we have our software deployment. It is a every module is a different microservices are available. See, this is the personal backing, this is the login, this is the loan. Like that, we have a different. If I want to change any software code. See, I don't want to stop any of my server. Simply, I'm going to be enter into this microservice. I'm going to be uploading this thing only, guys. That is the thing only here I written as a, okay. I don't want to stop any application here. Simply, I'm going to be enter into this one single microservice. I'm going to be update my application, and automatically this microservice will be automatically it will be updated. But in olden days, not like that. If you want to upload or modify any code, okay, then you have to stop entire this server, guys. You have to stop entire this server. That's what earlier days we are getting as a server problems. Okay, server problem. That time we don't know when it is going to be up. It will be take 2 days, 3 days like that. But here it is not like that. Within a minute or within 1 hour like that, it is going to be updated. Within a minute also it will be going to be updated, or it will take 1 hour like that only. Or else there is a no downtime also, it will become this microservice architecture. Now every company is following this microservice architecture, guys. Okay, that's what we are going to be use this Docker. That is a related because why you are going to be use this Docker is a here lightweighted, and it is going to be used in this microservice. You are going to be run very easily, guys. Very easily, we are going to be run. See, coming to here, very easily. Different microservices we are going to be run as a very easily, and we are going to be deploy our application in this Docker wise only. Okay, Docker. Docker is nothing but as a container. Container, we are going to be run our application as a container, guys. Just we remember that thing only. Okay. If anybody will be asking what is the difference between the virtualization containers, we'll just go for this slide. Okay. See here, starting I written those things only. Okay. When it is came, when it is came, all these things. Okay. In 1990s, how it will come after 2000. Now everybody is following these 2013 models only. Okay. These are the advantages only here I written. Okay. Can go through it, these slides. I will share these slides. Okay. Don't worry. That's the thing only. Don't panic. How many slides are there? For explanation only, I given like this only. Okay. These are physical missions, how physical missions it will be there. After virtual missions, how it will be there. After guest OS, how we are going to be installed. Why it is failed in different environments. Why it is failed based on the your dependencies, your softwares. Okay. Same softwares you need to be installed. Otherwise, it is going to be failed. Okay, that's what there is a different isolation. That's what we came into this Docker concept. It is came. See now everything is coming to one Docker image. One Docker image means see inside that image you already have your application code, your software, your platforms, your environments, everything it is available. Okay, then you no need to be worried about because everything it is containing as a container. Okay, everything is coming to the platform only. Okay, then only you can run any environment. Then you don't have any failures of any dev environment. There's no failures, any failures in test environment. It will become like this. That's what we are going to go for this Docker test. Okay. This is the thing only. And tomorrow we will be show you see how to run this all the things, how to install this Docker. Actually, we already seen how to install this Docker while installing SonarQube. Okay, how to install Docker, how to run as a one application as a one public image. I took it as a SonarQube public image, guys. Okay, I run and I showed also. Okay, now you can understand how I run as a SonarQube. Okay, then but tomorrow also I will show you. Don't worry how to install and all those things. Okay, just go through the slides. Docker is a very important concept. Okay, I will share this entire slides to you guys. Okay, tomorrow we will go for the all these things will be practical. Okay, how to install this Docker, how to create a image. Okay, how to getting the pull. Okay, and how to create a this Docker hub. Okay, how to push the image to the Docker hub. Okay, how to run this application. Everything I will show you guys. Okay, and we have a different key components also will be there like Docker file, Docker images, Docker volumes, Docker networks. Okay, this Docker compose. Okay, we have different key components. We will do practically all these things. Okay, it will be take few days time, okay? But step by step we will go, guys. And do you have any doubts up to now for this Docker? Hello.
No, Krishna.
Yeah, thank you. Abhi, tell me, Abhi. Do you have any doubt? Yeah, thank you. Okay, tomorrow onwards we will go for the practical, guys. Okay, don't worry. How to install this Docker, how to take a public images, how to install all those things, how to create a Docker hub and all those things. Okay, thank you. Thank you. Bye.
Thank you.
Thank you, Krishna.